Morning.
Hi, how are you doing?
Oh, pretty good.
Okay, I did you get the good news? The good news from me. I broke my Linux. I was trying to install VirtualBox and configure a VM with Ubuntu and Postgres. It just broke. So here we are from a Windows machine,
Oh,
but uh, no problem. The thing is, it's recording. That's the important stuff. Okay.
yes. Sorry to hear you broke your box.
No, no, no. Uh, like I was saying to the IT guy, next time I try to do some main stuff, I will call you. Just kidding. Well,
So,
uh, I was checking the last meeting, and I think I will get used to the project pretty quick. Actually, you're really good at explaining. So, what do you propose for today?
well, after we went through that, that other stuff, what kind of questions did you have, or what would you like to cover, I guess? We could start with that, and then
Yeah,
otherwise I can jump in on, something else.
yeah. Well, I have some questions. For example, from the ETL general flow, I had some doubts.
Okay.
Mm, how do I let me recall what I wanted to ask you. Mm, okay, okay. For example, you you mentioned there is some basic communication between the appliance and and the machine that starts the transformation and it. Yeah. How do you control that the 10,000 the million
Okay.
records yeah. Would you show me in the code,
Yeah,
please?
yeah. Let me hang on a second here.
Sure.
So I'll go ahead and share this, and I may have to kind of um, look through this a second. So on the config DB, that's Daz. So I just want to kind of first go in and look at this data set. If we look at the SQL, um, this is inserting into the tenant config data set. And so that's the schema tenant config, and it's data set. So this is a data set definition that the appliance is going to use. And, you know, it's got an ID name, description, version, definition, but really what it is it's a little easier for me to look at this, this definition. There's, and I will get to your question, I think. But this JSON, and it's basically an array of these, you know, name value pairs. And so if you look at this one, it's got IG check tender detail. So these are the 4 fact tables up at the top, you know, like IG check sales detail. So that comes from the source system, or that's the name we give it. You know, we read it with a no lock. So these properties are kind of what we use to build the SQL, and we can go in later and look at how we actually build the SQL.
I'm sorry.
Yeah.
So this is the structure. Yeah. Okay. You said you pull some data from the from the customer database.
Yep.
From using the appliance, and you you send it on you send it to a RESTful server. Yeah, the communication is via JSON files. Okay.
Yes.
But what you're showing me is the data structure, the metadata.
I'm showing you the metadata that the appliance uses to build the select statement and the from the source system. So this structure is read into the job, and so when I told you last time that we iterate through each data set and then get a result reader and then start chunking the data up and sending it, this is what it uses for, you know, this basically each one of these is a data set that the appliance Java code uses, and it says, oh, I'm gonna go through this IG check sales detail. I'm gonna build up my select statement using these things. That the schema name, it comes from the IG. This one comes from the IG business database check sales detail table. It has basically, I'm trying to see there, 100, looks like a max session rows.
It's like 1 million.
It's what?
I see 1 million.
Yeah, so that's the, it will grab 1 million and then it will trigger a transform. That's what this max session rows controls. And then here's select columns. Here's all the columns we grab, right? And so if we kind of look at this, you know, like some of them have, oh, I'm trying to see here. I guess it's maybe in this watermark column. This water. It's a little side note here. This watermark default column. If you don't have a watermark for the table, it'll run this select first to get the beginning watermark. If you've never pulled this table in before, otherwise, if we already have a watermark, it just grabs it, and this is the column it compares against. So this is what we do for each of the data sets, and it does it in this order. You know, it'll start out and it'll start working on this one, pulling them till it gets to 1 million, and then, you know, trigger a transform, work on the next one, so on and so forth. And then, like these down here do not have a watermark column defined, so we basically get everything out of that table each time. Most of these are pretty small. The only one that's not is menu items, and so we actually have a watermark column defined on that. So to answer your original question, let me switch over and look at.
One question, please.
Yeah, sure.
How do you decide to which table to apply a watermark? What is big for you?
Yeah, so the fact tables, these first four ones and menu items, actually have in the IG database this transaction data ID. So we basically use that as our watermark. If there's a new transaction data ID, then we grab that and bring it in. And so it's not perfect. These other ones, like Profit Center, there's no real good watermark from IG. So we go ahead and we said, hey, we're going to pull those in every time. They're not that big. This menu item one, we used to pull it kind of once, but or we used to pull the whole thing every time, but in some bigger systems there can be 3 million items in that, and so we basically pull in the menu item dim ID. The downside of this is that if they change an existing menu item, we wouldn't pull that data. But most of the time when there's a change, they add a new menu item. That's why there's so many rows in that table. So if they change a price, they don't update an existing menu item. They create a new one with an effective to from date. So it's relatively safe to do this. So we initially pull those items, and then we just look for the deltas, any new menu items since the last ETL. But on a lot of these others, like discounts and things like that, they may add new ones, they may update them. It's not that big of a table. Same with employees, they may update it if somebody's, I don't know, well, that's Profit Center table, where do employees go. Like if their primary job code changed, but it was the same employee, that's why we have to pull all of them, and you can see that there's no watermark column defined. And so we do sort of in this structure, this structure defines all the tables we want to pull from, all the columns, whether we're grabbing everything, whether there's a watermark that we're going to keep track of and change. And so this is how we drive that application. Does that make sense?
Yeah.
Okay.
Totally makes sense. So it's my understanding that this is the structure for all the data, this is the metadata for one customer in particular, or for all customers
Yeah.
that I.
Good question. So this is, you'll notice, is in reference data, and we've defined IG, data set 0, and so this is all the data. These are all the tables, and it's predefined. So anybody that's, right now you can either pick, and I'll show you this in a second, a job that uses this data set, this IG data set 0, with this combination. So everybody uses this one for IG, everybody uses this one for LMS. You'll notice that it's a little shorter here. We basically have facts again near the top, and this one always has, like, this initial load duration is specifies how far back in time we want to go, and the LMS job type in the appliance gathers data through calling a stored procedure, and so basically you tell it, hey, I want a reservation data, and I want, 1 million and max, and then if we don't have a watermark defined, which is in the state table of the tenant database, if we've never loaded this before, it's basically go 3 years back and start pulling data there. But the rest of like if we've already pulled that job goes, oh, I'm going to start from the last watermark and then make this call. So it's much simpler to make these calls because we don't define the columns that come back. That's defined in the stored procedure that we call. So when we call that stored procedure, and it's always the same one, but we pass in the table name, so reservation, it it's going to return a very specific record set to us, and we just process that record set. That's why in this metadata for LMS, we don't have like column selection and things, because we're not building SQL ourselves. We're just calling a stored procedure, says, hey, give me the reservation data, give me a maximum of 1 million, and away we go. In this case down here in room type, we pass in a null for initial load duration. So it says, hey, every time we're going to pass in a null, and you're going to give us everything that's in the room type table. And these are, as you can imagine, room type has like maybe, I don't know, 7 or 8 rows in it. It's not much. Same with rooms. Rooms would be limited to, if it's a 250 room hotel, you're going to get 250 rooms back in this. So you'll notice that all this dimension data is we pass in null. And so when we set this up, we defined with the LMS guys the tables that we wanted to pull data from, and in their case it may be more like views. It may be multiple tables that they pull together. So there's definitely business logic on their side when we go in and we say we want reservation data and keep track of a watermark. There's logic on their side that we worked with them. So they wrote the stored procedures and made them available, and then we put this structure together to basically, we start with rate, we go to reservation, we go to revenue, and we make that same call, process whatever comes back. Does that kind of make sense?
Yeah.
Okay.
It makes the next question would be,
well,
how do you make it particular for a customer?
Yeah. Let me get to that. I think that this talking about this. Hang on, I'm trying to share a different app. I think this will make more sense here in a second. So this is, I'm going to go look at my config database that's out on my vApp. And so I'm going to look at, so this is a config database. Let me just see what's in here. So this, of course, in the public, the only thing we really have in here is that DB versions table. The DAS schema, again, really just has the static job types, job configuration, which is a particular job. And let's just, I'm gonna cover DAS first, but we'll get back to the appliance because they're very similar. So this is like I have 2 jobs defined for DAS. One is active, one is not. It's got a description. There's a version. Every time we update this particular job 1, it'll increment the version. Its type ID is related to this job type, so it's job type 0. And if you remember, that's the reference data. Are you seeing the? Are you seeing this screen here?
Yeah, I can see that screen, but I am having problems to hear you well.
Oh, are you seeing the results screen? I wonder if I just need to share my whole screen.
Actually, I am seeing your PG admin only.
Okay, let me just do the entire screen and share that. So you should see yourself now. I just wanted to show you. This is the job type. And I just wanted you, these are the definitions of the data sources, right? And this is a DAS job type, and so there's 3. Looks like there's 3 job types in here, but there's really 0 and 1 are the predefined ones. I put a kind of a fake one in there, but anyway, that's job type, job ID 0, or job type ID 0 and job type ID 1. They're slightly different. Those are the two canned ones that we deliver. So what I was trying to show is this one, this first job is job type ID 0. It's tied to tenant 2. There's a cron schedule. It says, its output file name is going to be test. Goes to this. We keep track of the sequence numbers, which end up being part of the file name. Whether we enable compression, watermark, things like that. So this is a DAS job. And then, so those are the jobs. These are the job types, and then we have an audit table. That's for DAS. And now going to the tenants. I'm going to go through these 4 tables. So appliance is pretty easy. It just, you can look at what's in there. Basically, it has the appliance ID. So that way, when an appliance calls our RESTful service and says, hey, give me the jobs for my appliance, we basically look up this UUID, and we get its appliance ID from it. And then those are foreign keys into these data sources, I think. I've got to look here. So anyway, the appliance here has properties that it uses. Like there's, let me take a look at what a row would look like. So you've got the appliance ID. It's got a name. We kind of give it this name by default. And then rows max fetch. I think sorry, didn't mean to jump around. I think that's how big, and I've got comments in the code what these values are, and I think in the admin tool as well. These rows max fetch is, I think, what we tell the connection, like what the prefetch value is. So it will prefetch 2,000 at a time. We poll every 30 seconds. This is how often we check to see if jobs have changed. Got some timeouts. Init call wait time. So a init call wait time is when you actually start a job, how long you're gonna wait. They're kind of single, and then these are kind of like how many times do you retry, service failed retry count, and these are, I think, they're documented in the admin tool. But this is basically you have a row in this for every appliance, and that's what gets returned with configuration data to the appliance. Data set is what we just looked at, I think. Yeah, and so it's this data set definition that we just looked at a minute ago. And so there's 2 types. There's a 0 and a 1. One is IG for IG data sources. One is for LMS. So, for instance, going back to this particular table, let's say they decided that they needed some new column in IG. And so what we would do is we would obviously change our database staging table. We change the data warehouse table to add that new column. We would change our stored procedures to handle transforming that new column along with the rest of them. Or maybe there's a new table, right? So we'd add the table and staging in the data warehouse and then a set of transforms for it, add it to that that list of functions that we call so that it would call those new stored procedures. We'd handle our upgrade script, so we'd actually, there'd be the set for a new database, and then there'd also be that upgrade. And that's kind of what we covered last time. So now that you've got this new one, we would also have to add a new data type in here, and it would be, you know, it would have a new ID. It would be 2, it would be InfoGenesis, and it would be version, you know, 1 or something. We'd give it a new version, but it would, the ID would be 2, and it would have a new set of JSON definition, so it would add that new data set in there. So we would not only have to change our schema for staging, data warehouse, the stored procedure transforms, we'd have to add a new job type in here, and then when somebody created a job, they could pick the old one or they could pick the new one. And so that's how we would change the job. We'd still keep the old one, we'd add the new one in here. Yeah.
So I'm sorry. So the old one, yeah, you're basically keeping track of history of the jobs related to some state of the source that is going to travel through the stay in data warehouse and finally to the reports. So
Well, yeah, and these data set definitions define what you're going to pull out of the source system. So you could, you know, conceivably have a new data set definition that only pulled part of the data or pulled more data. And, you know, maybe it was something where they said this customer needs more data, so we're going to extend the staging tables and the data warehouse tables and the transforms, and then we're going to define a type special just for them that would pull more data. And so that, and again, this is all about getting the data from the source into the data warehouse. On the other side, about them using reports, that's all with Mondrian cubes and the Pentaho. It's basically about defining the Mondrian cubes. But in this setup, you to add additional columns and things for IG or additional tables, all you really need to do is provide the schema in the database, the transforms in the database, and then add this new job type that defines what that is. But you don't have to change any of the code, because the code is all driven off these data set definitions. Now, before I get into data source, I wanted to show you the tenant table, and so we'll, if I can. So this is really the jobs. So when an appliance comes in, let me just make sure I'm not lying to you about. It's got a tenant ID. Hang on a second. I'm going to move this window over. So data set. Oh, I'm sorry. The tenant table that I just opened up is really it gives a tenant ID. You know, so I've got 5 in here. It's got a name, and then basically it's the connection information to the server. So here's the servers that it is. It's got the database name, username, and password. It's really the connection information for a tenant. And so now when we get to data source, which is not necessarily the best name, this is the actual.
I'm sorry,
Rob. Yeah.
By tenant, you mean a customer, a person has a company has space on the database, some staging space, some data warehouse space, correct?
Yeah. So a tenant's going to have is going to have a tenant database, a BA server, and then their access to it is logging into the BA server. And then on-premise, if it's an on-premise customer, they will have an appliance and one or more sources, like it could be an IG source and an LMS, or it could be 2 IG sources and an LMS. And for every data source that they're going to have one of an entry into this table, this data source table, which is not really this is really the appliance ETL job table is what this is. It's called data source, but that's just because it was. Never mind why. Anyway, that's and so like here I've got basically two jobs. They're tied to appliance 1, my appliance 1, and so if you went into the appliance table, you'd look up appliance 1 and you'd find out its ID. So if you had, like in our data center, which is serving multiple tenants, you would potentially have, they'd all be potentially on the same appliance, but then you'd say, hey, for tenant 1, I've got these. For tenant 2, I've got these. And in the same configuration database, you may have appliance 2, which is to a different tenant, and that may be appliance that's behind somebody's firewall, and they've got, in the one where we said they had 2 IG sources and an LMS, they'd have 3 jobs all tied to appliance 2 maybe, and it would all be tied to the same tenant. Yeah.
I'm sorry to stop you right there. To make things more clear to me, what we are seeing there is some sort of testing scenario, some production scenario, or what are we seeing?
This is my test environment, right? And so I've got one appliance that runs, and then I've got 2 jobs. One is an LMS job, one is an InfoGenesis job. And then does that make sense? So my appliance fires up and says, I'm appliance, and it gives a GUID. The Sprock basically goes to this appliance table, finds out the ID, comes to this table, and says, oh, for appliance ID 1, send all these rows back. And these have a schedule and a data source type tied to these, and more specifically a data set. So it says, for this job you're going to run this data set, for this job you're going to run that data set. And the first one, we looked before, the data sets, there's only 2 right now. There's an IG1 and an LMS1. And then whether the job is active or not determines whether it actually runs this schedule. So in this case, there's only this LMS one that I have set up to run right now. And it's, it's got a version. One of the things I want to, and then it says, well, what JDBC driver it's going to use, and it kind of has let me think about this for a second. The connection string. Trying to think about this. This connection string at the job. Oh, yeah, of course. I'm sorry. This connection string. So this is a job that you're going to run, and it basically this driver class name and connection string and the username and password. That's for your source system. So this table for this job says, I'm going to run this LMS. Sorry, I'm going to run this LMS job according to that schedule, and I'm going to connect, with this driver to this machine with that username and password. So that's all. This contains all the information about the source that you're going to pull from. Because we've also said that it's this data set, then that's what's going to drive what we select or what we're going to call the stored procedure list that we're going to call. And I guess that's all I have to say about that. This, you know, and the DAS and the other one are very similar. This basically, it's like, when are you going to run this? What are you going to connect to? And what are you going to pull? And then it builds, the appliance builds up that message and sends it. And that's you know,
I get the idea. That would be
oh,
pretty much it from extraction.
okay.
From extractions, from data extraction from the source.
Right. And the other thing that's kind of interesting to look at is when you look at the admin tool, you know, there's these, this is for adding appliances or listing them out. And then, you know, there's an update. These are all the things that you can update. If you look over here, this sort of describes what they are. And you've got, you know, read timeouts, and, you know, a lot of these things are optional, and get set to default, just like appliance add. You really only need to give it the name, and you know, the message version. We're not really utilizing message version per se right now. And then I wanted to, but it, you know, but it's a good idea to, so this would be like if you had a brand new system, you'd go ahead and you'd add an appliance, and then you'd do a, you know, add a tenant, and then this is what's required in this, and I can show you what. That's not what I wanted. I thought it was. Hang on a second. So if I go tenant, so here's a tenant, or maybe it's better to look at let's look at a tenant, I guess, right now. Then when you so if we actually look at what the parameters look like when you call this, you know, it's you end up calling the jar file and you pass in the server. In this case, it's going to write to my local host. So it's going to expect that there's a configuration database locally, you know, with this name. But basically, you would change all these all the way up to, so this port, DB name, username, and stuff, all the way up to this action tenant add, is your configuration database. So all these parameters, basically, you start with passing in parameters to the configuration database. Then it has the action that you want to do, and then any of the parameters after the action. So in this case, I'm going to add one. It's going to be called junk. It's this host name. It's that DB server, and then username and password, junk and crap. So that the only reason I'm showing you that is the command line sort of way we run the admin tool, and then these are where the parameters are passed. So then you've kind of got this, like, for adding users and stuff, that adds to the tenant database, and that then allows you to add specific users and their roles that the BA server uses. There's one here for just listing out watermarks in a tenant database. Let me just take a look at that one. So this selects from table column watermark. I'm pretty sure this is for watermarks in the let me see, retrieve watermark information from a tenant database. So yes, this is the ETL watermarks, and not like DAS watermarks. And so you got users, we've got adding tenants, location list pulls the locations from and lists them out with some potential filters so you can look for a specific enterprise, division, or store. Because some of the things you need those for, like users, when you're modifying a user and you want to assign specific locations to them, you need to actually find out what those IDs are. Then you've got listing out the ETL data sets. This is for adding the jobs or modifying the jobs, so you basically got your CRUD operations there. Listing out data sources that I think that the data sets need. So this again is, you know, those, is it an IG data source or is it an LMS one? And then you have, you know, sort of these DAS job ones for adding a job, adding a filter to the job, so your CRUD operations on that, listing them out. Like I said, adding a filter, removing a filter, that's for if you want to filter out and only do DAS exports with enterprises or a specific data source. And then listing out your audits from the DAS table. And then this was the appliance one. So basically all those tables that I showed you a minute ago for DAS and for the appliance, those are all manipulated through this admin tool. And so this is a good place to kind of look at what gets updated, what gets modified. It's good to list them out. Of course, you as a developer can go right to the table like we did through the PG admin tool and look at stuff. But that kind of gives you an idea of what how the appliance is controlled. It's basically you have to have a row in the appliance table for the appliance. You have to have, you know, your tenant defined so that we have connection information to it. You have to define the data source, which is really the particular job, and then of course important to that is which data set. And again, I apologize for the name data set and data source, but it's really, you know, ETL job and then which type of job is it? Are you going to pull IG data or LMS? So did that kind of tell you how we, I mean, you originally asked where's that setting for the number of records, and I think, I got to find it, I think it's in here in the data source. Just take a look here. No, it's not there. So if it's not there, let me just see if it's in here. Yep, I thought we did 10,000 at a time. What we got here? 2,000? I don't think it's.
Yeah.
Oh, this one.
That's exactly why I was asking you.
Yeah, it's.
Were we? Yeah.
This is the number. I probably have it to 2,000 on mine because I didn't want to do 10,000. I'm pretty sure this is the number that controls how many records we send in a batch, and then I'm just looking here. I'm sure that that's the number that controls.
For testing purposes.
Yeah, it controls that. The other number. Where did I see that other number? Was that in the? Wasn't in the tenant. It could have been. It could have been in this. Oh, let me. Yeah, it's here. It's actually in this data set definition, so that, and the reason it's there is that, like these ones, you want to pull so many and run them, but on the discount details, you want to do more um, or you want to do less than the million when you pull those in. There was a reason we did this, and I can't remember why this number was less. I think it was less because we used to, and I'd have to look at the code. We used to pull like 1,000,000 of these, 250,000 of these, 1,000,000 of these, 1,000,000 of these, and then all of these, and we would run it. I think, can't remember now if we changed the code and it processes like all the check tender details, the discount details, the check item details before it calls the transform. But anyway, this did allow you to kind of adjust it at the data set level, like how many do you want to do before you call the transform. And it's possible, looking at this now, that if we did change that logic, that we might actually want to push this one up first, the check sales detail, ahead. Like this should be the first one we do versus what we do now, where we pull this. I just realized that depending on the logic of that, we might want to pull the checks first so that you had all the checks. Because otherwise what might happen is if we do this one first, check tender detail, it's going to have a bunch of references to the checks themselves, but if you haven't actually loaded those checks yet, then you'd end up with a bunch of those left in the staging table waiting for checks to finally arrive. And so I'm thinking that this order, especially if we're doing a historic load, may be wrong, because we did change some of the logic in the appliance, and it almost looks to me, I'd have to go back and check that what I'm trying to say is, in the past, the logic was you'd pull a certain amount from each one of these tables up to this max session rows. Then you would call the transform, and we may still do that. So it would be okay to.
I'm sorry. So a question came to my mind right
Yeah.
now. Why would you put a fixed number of records? Let me put it on a business case. You know, assuming. Oh no, you mentioned you basically pull all of the records of the dimensions, and basically the transactions is what you are limiting to a million, so it shouldn't be a problem with the joins. No question. No question. Sorry.
So if we're doing a historical load, let's say 3 years worth of data, you might end up having like 30 million records. And so what we wanted to do was kind of, and still you would be sending like batches of 10,000 or 20,000 or whatever to the RESTful API, but as you're processing this data set, this first one, let's say, you have the option of, do you want to get all 30 million of them, or do you only want to get like 1,000,000 out of each of these tables and then fire a transform, so that you're, because the one thing, it's like you could get them all out of each of the tables, and so you're dumping into the staging table, so now you've got like giant staging tables, and then run the transforms. We wanted to be able to control that a little more, so we said, okay, let's go and get like a maximum of 1,000,000 out of each of these tables, and then run the transforms. Does that make sense? And it,
Yeah, it makes sense.
it, it
I am trying to think what could happen according to your current transformation rules. I don't know. What if what if you do what if you pick let's say on the final record on the million record you pick a an invoice and you don't you don't pull the whole order. So you are going to transform, you are going to insert to the fact table, but the transaction, but the invoice is incomplete, right?
right. And more specifically, like let's say you brought this check tender detail in, but you didn't have the check for it, which is this one down here. So you bring this one in, you insert it into um, the check tender detail table, but then you've got to keep it because you do have the transaction ID, but you won't have the check that it's actually tied to, um, and so this data doesn't actually show it, but there's actually this check tender detail needs to point to this actual check um, based on its ID that it gets inserted. So if you don't have this check in the data warehouse yet, then you go ahead and you put this one in, but you keep it in the staging tables because it has a missing dimension. So the check ID that gets inserted for this tender detail record would be like a -1, like it's a missing dimension. And so then when this check finally shows up, you'll hook this tender detail up to that ID. Then you can take this record out of the staging table. That's how we handle, late arriving dimensions.
Yeah. Totally clear now. Thank you.
And what I was looking at this before is we would pull in 1,000,000 detail records, 1,000,000 discount records, item records, and so it would be 1,000,000 each on these. But I was thinking, and I have a doubt in my mind. I think that we changed the logic so that this first one we process till we get to 1,000,000, and if we got to 1,000,000 on one of these, like this one, this check tender, we would call the transform, which means that there's 1,000,000 checks missing on a historic load that we've missed 1,000,000 records, and so they would stay 1,000,000 of those tender detail records would stay in the staging tables, and we would have to process those. I think that we need to look and see if we change the logic of that. That would mean that we should really move check sales detail up to the top, and then then these others don't. It doesn't really matter the order of these others, but it definitely means that check sales details need to be there earlier than like check items. And so I think I need to go back and look at that and see if we need to change the location of this, because you really want those checks to go in, get totally processed, and out of the staging table either at the same time or before you bring in these others, right? Does that make sense?
Yeah. That's exactly what I was going to ask.
That
That comes something to my mind.
Yeah, and it wasn't a problem before. In fact, this was an okay way to do it because we we either currently do or used to do where we grab a max of 1,000,000 out of each of these tables, or in the case of this one, the reason we lowered this number is you have quite a lot less discounts than you have checks. Not every check has a discount, and so what we were finding is that we used to grab a bunch of discounts, like 1,000,000, but you hadn't loaded the checks yet, and so they'd stick around, and that table would continue to grow. The staging table would continue to grow, waiting for the checks that these discounts were tied to appear in the system. So that's why I need to go back and check to see if we actually kind of, load an entire table at a time, transforming every 1,000,000, and then move on to the next, or do we go through this entire list, grabbing 1,000,000 each, or in this case 25,000, 250,000, and then do a transform, because that would really affect the speed at which we do our historic loads, like we were talking about. So anyway, I hope that gives you a better idea about how the jobs are defined, and kind of what the role of that configuration database, defining appliances, defining tenant connection information, the data that we've defined for this data, and kind of that the admin tool allows you to manipulate the jobs and things. It does not allow you to manipulate this data. This is static data, so we as developers control control this data set definition. And so every one that pulls this data set gets this definition. It's not unique per customer, and that's true of the DAS jobs as well. You'll see that this reference data, this gets installed with the database. So we have two job types here, and the only difference between these two job types, I know we've got 3 files. One is JSON, just so it works better in the editor. We wrap it in SQL. This is the one that actually gets installed, that actually does the insert into the table. And then this is the XSD definition. The difference between this one starts with locations, and we added a job type 1 because what they wanted was systems. And then every one of these tables has a system ID associated with it, so they know which system they pulled from. Because before, in the job type 0, it didn't have systems, so you had like employees, but you couldn't filter out which employee table was it. The IDs were all unique in our system and matched up, but you couldn't say, give me only the employee IDs from this particular system. And so that's why they had wanted that information. So that's why we added a job type 1, added the system table. It's got an ID and a name, so it'd be like, Compass System 22, and then every one of these tables has a system, because the data we pull from IG or from LMS for a particular system, those things like store ID and things are unique within that system, but you bring in another system, so you have 2 different IG systems. Well, you could have 2 store IDs, ID 12s, but because they come from different systems, they're different stores. So that's why they needed system ID to make it independent of which. So at least they could know, this ID that we give them here would be unique for this set of data, but you'd still have potentially 2 store ID 12s, and you kind of need this system ID to know that, oh, store ID 12 in system 22 is this, store ID 12 in system 19 is something else. Anyway, that's just the DAS one, and then likewise we got this reference data for IG and LMS. If we ever change and add more stuff to LMS or to IG, we would conceivably have another, we'd have like an IG1, something like that. And likewise, we only have 2 files here because we don't need an XSD for these, because the customers don't really see that. That's really our own internal thing. what else can I say? And again, that stuff's all stored in the config DB, in the tenant DB. The only reference data is that we put in as our processing codes. Oh, that's in the config part. Let me look in. This default, yeah.
Maybe we can
We
talk
can talk
about
about
how
how
you
you
trigger the
trigger the
transformation
transformation
process.
process.
I don't know.
Okay.
I don't know.
Yeah. So, well, and this particular table is kind of good for that. We've got, we're inserting into, we have this table, the data source type, and is that right? No, we have loading sequence. So we basically insert the names of the functions, the stored procedures, into the staging DW loading sequence table. And so it ends up with a sequence number and then the name. So we run these. The sequence number basically is the order in which we're going to run these stored procedures. So we've got a set of stored procedures that we run for IG, set of stored procedures that we run for LMS, and it's basically like I told you before. It's pretty much these five. We have sort of an initialize, a dedupe, a match ID, the insert update, and then sort of a finalize if there's anything we need to do. And so we do this in this order. Of course, we've given these ones. They start at 100 and go on up. It was just so that you could say, for this particular type. For this particular job type, in this case 2, and in the other case it's 1, go ahead and give me all these functions in this particular order, and then what the service API does is calls these things one at a time. So let's go look at IG Profit Center or any one of these initializes. So this would be so these all take the same. These all take the same parameter.
These are the common procedures to transform data.
Yes.
Same question. How do you make it particular for a customer? Because
You don't.
I don't know.
You don't make it
Okay.
particular for a customer. You make it particular for a job type. So
Okay.
if it's an IG job, then this is the set of stored procedures we'll call. If it's an LMS job, this is the set of stored procedures we call. And then looking at one of these, there's the name. They all take the same parameters. So the service API has the list of names, and it knows that it's going to call them exactly the same. It just needs to do them in order and wait for them. And so in this case, it's going to update the IG check item staging table, setting the processing code to unprocessed for a particular data source where the processing code is not unprocessed. So this limits it to, we know that got passed in, so the service API knows it's working on a particular data source ID like system 22 or whatever, because there's one job per system. So you don't have a job that crosses systems, systems being the source system. So basically the appliance loaded all this data and sent a message to the service API that says I'm done for now, and so this thing went, it got this list of all these stored procedure names and is calling them one at a time, passing in the job name for auditing, the data source type, the particular data source ID, and then that's why you could have multiple appliances or multiple jobs on an appliance all dumping into the staging table at the same time. And then this one particular job says, I'm done sending data, go ahead and process this. And so that's why then basically it just limits by data source ID, because there shouldn't be anything else dumping in from that data source into this staging table. And so that's how we get that's where the list that controls the order of the transforms and the transforms that we do. So there's not customization for a tenant for a specific data source. You either do IG or you do LMS. That's not to say we couldn't handle that, but what you'd have to do is you'd have to obviously in your ETL job have another LMS type that got different data for you, and then potentially you'd have to this set of data here is for type 1. So somebody's coming in and saying, I'm doing type 1, this is the set of stored procedures I run. If you had a type 2, you would come in and say, well, give me all the functions for a type 2 transform. And so you could in your ETL definition in the config database for the data sets, you could develop a new one that pulled more columns or less columns or whatever put into the staging table, and then you would also define a list of these stored procedures that you wanted to call for that type. Does that make sense?
Kind of. It will.
It's.
I will look at that.
I mean, you've got very good questions. It's so I've kind of shown you that still stayed in the database where we pull that list, and I know you've had to take it on sort of on faith that that's what happens. We can actually look at the service code if you want to get down to that level right now. So it's in this service project. It's down under. So I believe that this. Let me just look at this. So here's the interface for that service. You've got to call the data initialize, and this is what returns the watermarks. So when the job starts, it calls this. It does a couple of things. One is it makes sure that it goes and checks to see if a transform is running. If it's running, it comes back and says, nope, I can't give you the information. If there's no transform running, it gives the watermarks back to the caller, which is the appliance, and then it knows that it can go ahead and start sending data. Otherwise, it can't send data until there's no ETL or transform running. So then you've got basically, I'm sending you a bunch of data, and if you look at this batch service request, and I guess what we could do is go over there. It basically has this sort of a structure, like which appliance, what's the session ID. We make sure that we pass this around. So every job, when it runs, it starts a session ID. It's just a UUID. But the important thing is it kind of says, where's it coming from, this appliance. It's for this tenant ID, so that when it gets that batch of data, it can look up the tenant ID in its cache and see if it has connection information, grabs the connection information to the database, and then basically does a bulk copy into that staging table. And then you have, which data source ID is it? It's got a name, and then we don't really use this additional properties much, although we could, but that's basically it. This list of data sets, I guess we could go look at. It has a watermark, so we check watermarks when we're sending it that there's no gap in the watermarks. So when it dumps into the table, it's going to say, you better have this previous watermark, or we can't do this. They better match up. So there's some kind of checking with these watermarks, and then basically data set name. Where is the data? I'm trying to see. So it was in the batch service request. Oh, it's this list of, you have a list of data sets. Sorry, I'm having to go through here. So you pass it a list of data sets. Oh, it's this datum object is where the actual data is, and it's basically a map of name-value pairs. And so really when this thing gets this list, it better match what you're trying to dump into. So there's this sort of agreed upon, we defined all these columns for a particular data set, and the name of the data set. So when this thing, this is how we pass it back and forth, is basically this datum, which is then the map of the column names and the values. And so then the actual service code, when it's dumping into the staging table, does a Postgres copy, and it basically builds this thing up. And it does some checks ahead of time to make sure that the target staging table that you're dumping into, which came in this request, has the columns that you're trying to dump stuff into. And it's a little like, it doesn't like it if you have more columns and you don't have places for them to go. And I think it also complains if the other has more. I'd have to look at the checks to see if it will allow less data to go in there. But basically, it's pretty simple. It's just like you got a name-value pair. Name is the column name. Value is what you're going to stick in it. And it looks at the staging table types and does some, like if it's a date time, it converts that string to a date time, dumps it in. And but it does it with the Postgres copy. If you were to change over to SQL Server or something, you'd have to kind of change that layer to write into that table in bulk. Do a bulk insert or whatever. But it basically it does some checks when you get it about watermarks and columns, and then it dumps straight into the staging table. So it's pretty simple. Going back to this. Appliance configuration, ETL data source schedules, and ETL data sources. These are what now go to the, and this was the latest stuff that I had added a while back. These go to the configuration database, and first, when it first fires up, it calls this and it says, "Hey, I'm this appliance. Give me my configuration," which is like, timeouts and retry counts and things like that. Grabs that stuff so that it can fire up. Then, a separate thread periodically pulls for the schedules and looks for any changes in schedules, like if somebody updated those. So again, it calls through this API to the configuration database and then pulls this stuff back. And then this one, the ETL data sources, when that particular job runs, it goes and gets that data source information based on the ID. And again, it comes, the appliance calls this goes to the configuration database. And then you can kind of look to see, here is, the initialize, the upload, code, and what, let me look back at this one. This complete, this is what the appliance calls when it wants to trigger a transform. It basically says, I'm done sending data. And so then what this does is this will go out and trigger the transform. And we can actually look at that. So this is a complete, does some stuff, and it calls complete data, which is in the service, implementation. Again, this is, so it calls this, builds up a new response. Let me just see where, so what it does is it launches a transform and returns right away. So launch transform, let me find it. Been a while since I've been in here. So this is where we call to get the set of functions. And then let's just DB transform. I'm pretty sure that we do this. Yeah, so we add this to, so it's on a separate thread. That's what this stuff is, where we get the executor and we execute the job. So when that complete message comes in, this thing fires up, goes out and does some stuff to prep this, and then runs it on a separate thread to go through all those transforms. And so that's sort of almost a non-blocking call. Basically, it signals it, and then the appliance, if it has more data to send, will call that initialize and wait for the initialize to actually come back and say that it's okay to send more data. That's sort of the handshaking that goes on with this. We'd have to dig in a little farther to show where that actually happens, but that's the concept, is that it sends a complete message, the transforms get fired off in their own thread, the call to complete returns right away with an okay, and then if the appliance has more data to send, it will basically block waiting for the initialize command to come back and say it's okay to send more data.
Robert.
Yeah.
I think I have seen you have a meeting in 10 minutes. And
oh, I don't. That's Ravi's not here, so I don't. But if you have too much information, we can do another one later this afternoon, whatever works for you.
Yeah, I would prefer that.
I know it's a lot to kind of listen to and follow along, and sometimes a person needs to kind of just like, let me go through, now that you pointed out some more areas, go through and kind of look at it myself and come back with more questions. So I totally understand.
Yeah, what I would like to do is to first of all get my computer back and try to try to set up an environment and a development environment and clone that code and check it out, because I haven't had the opportunity to check it out by myself locally
Right.
yet. But I think for now what is pretty clear to me, I think, is the extraction process. The transformation, not exactly clear, but it will get more clear when I check the code. So
Right.
what I would propose to you is to take the option when you allowed me to do another meeting later today. Let me let me propose this. What time works for you for another meeting?
Let me just look. So we just have our reporting stand-up. So I mean, I am open today, except I'll probably take off around 3:30 and then take this call from the. I don't know. Can you still see my screen?
No, actually I can't.
Oh, okay. I just have a with the analyze with the QA team. I just have a phone call with them at 3:30, and you're probably done by 3:30 my time anyway, right? Or getting close to it.
Mm, your 3:30 might be. I have no problem to keep this conversation
So,
later.
so the only thing I have is a reporting stand up at 1 p.m., which is I don't know what time your time, but I'm open other
I
than that.
Go on, go on, go on.
Oh, I'm so that 1 to 1:30 my time for the reporting stand up, which I think you're going to be in anyway, or we're invited to. That's the only thing I have today. So I'm open. I'm really open the rest of the day until the 3:30 call, and I usually take that from the car. So, anytime between now and 3:30. So your
Okay,
choice.
okay. I would love to see the backlog. Maybe with the backlog, I would get a more clear idea about the issues and figure out or think about how would I solve them. Mm,
Yeah, I mean, so our biggest really issue is, and and maybe that's what we go through this afternoon is looking at Compass that's in production, sort of that machine and some of the reports. There's some things that just take a long time to run, and so why don't we plan on so between now and when we meet? So why don't we meet? Sometime this afternoon. I don't know, 2 to 3 or something like that. My time, whatever works best for you. And then during that session, what we can do is we can go through the um, running the reports that the customer has, and we can kind of look at the BA server and what it runs. And unfortunately, we don't have access to their database, right? We can run reports through the front end. We can look at what Mondrian is running for some of the SQL. We can look at the performance of the machine, things like that. But I think if to get in and do tests, we have access to the integration environment, so we could potentially log in there and look at that. But that might be a good, we've discussed a lot of like code, how the ETL works. There is a performance problem there with Compass that it took days to load the 3 years worth of data. And sometimes it runs within seconds, those transforms, and sometimes it takes 20-30 minutes or an hour to run, and I don't get it. They restart Postgres and then it fires up right away and runs. But we don't really have issues with most new customers. Like Lifetime Fitness was one where they have an appliance behind their firewall. I mean, it took hour and a half to load all their data in, and it was done, and they were up and running. We don't have performance there. Where we have performance problems is with Compass, and they've got like 1 billion items in the check items table, and if you look at if you look at the fact table transforms for, or the transforms for the fact tables, they do an extra, there's some extra transforms in there that actually do the aggregations. So we add checks, and then we roll up into check item hour, check item day, check item month. Same with the discounts and the tenders and the checks themselves. And it's really on check items hour, which is our lowest thing that we expose to the customer. We don't actually give them access to the item table. We actually give them item hour. And there's still quite a few rows in there. And sometimes we were having trouble with, like, when it would try to add an enterprise filter, it would end up going to that hour table and then trying to do a distinct on enterprises. It would just take forever to come back, and would eventually time out sometimes. And so we added more aggregate tables for like enterprises, cashiers, things like that. And so this afternoon, why don't we kind of go through, again, that's sort of in the database. I can show you the tables. We'll get out of the database, but then I'll show you what the Mondrian cubes do, and then how you can run a report and then see what Mondrian is outputting as far as SQL goes, and that'll give you some more exposure to that side of things.
That would be great. That would be great. And from that, we could, I know, I could ask you more properly, you know, okay, what's the transformation that fits that fact table, and we can, I could figure out more properly about the code.
Yeah,
Yeah, yeah, yeah.
I,
That would.
I know that, it's a new system, and there's, I mean, it all ends up being the same once you know it, but it's kind of knowing where these things are, and getting comfortable with, the code, the transforms, the database structure, what's the BA server and how does it do its stuff. I mean, I realize it's a steep learning curve. So, we'll just, and I don't mind repeating myself. So, and there's no stupid questions. I appreciate the questions you're asking. And, I do think I'm going to go back and look to see if we change in the appliance, how we spin through those, because I realized that could have affected our historical load if we ended up having tons of things in the staging table that never got out until the checks finally got there. I need to go back and revisit that sequence of events, and we can either do it together if you want. I don't know how, like, if you like going through Java code, or if that's not as much as your thing as database, or I can just go in myself. So either way.
We'll see.
Okay. I think I'll look at it ahead of time, and then that way I can point out what I found out and show you what I think needs to be changed if we change it. So we'll do that then. So, okay, well, go ahead and schedule a meeting and put it on my calendar.
Okay, well, I'm going to have some lunch.
Okay.
Okay.
See you later.
See you later.
Bye.
Bye.